You may pause this video at any time to take notes. I want to talk about the first kind of current flow, which is DC, direct current. Current flows only in one direction, and the circuit has polarity, negative and positive. The next kind of current flow is alternating current, AC. Alternating current means that current flows one way and back again many times a second. In the United States, it's 60 times a second, or 60 Hertz. Hertz is frequency, cycles per second. In the next few slides, we're going to talk about using simple math to determine if we have the right measurements, to kind of predict what we should have in a circuit. E is electromotive force, which is what we measure in volts. R is resistance, we measure in ohms. And the symbol for ohms is the omega symbol, seen here in red. I is intensity, and that is our current flow that we measure in amps. This is what we call the direct current Ohm's Law wheel. With this wheel, we can solve any DC circuit using simple math. For now, we're only going to focus on three different formulas. At the 1 o'clock position, we have amperes. We can determine how many amps we should have by dividing our volts by our resistance. At the 4 o'clock position, we can determine how many ohms we should have by dividing our voltage by our current. And we can determine how many volts we should have by multiplying current times resistance. To break this down even simpler, draw this out in your notes. Here is how we use this very simple wheel that we created. By knowing two values, we can calculate the unknown value. By covering up the unknown value, we've created a multiplication, I times R. So let's say we have 4 amps and 3 ohms. The answer would be 12 volts. 4 times 3 is 12. Let's say we want to figure out how many amps are going to flow through our circuit. We take our voltage and divide it by our resistance. When we cover up our unknown value, we've created a division problem. So let's say we have 10 volts and 2 ohms. What is our amperage? Our amperage is 5 amps. Let's say we would like to calculate how much resistance a device exhibits on our circuit. We would cover up the unknown value, which is the R for resistance. We've created another division problem, E over I. So let's say again we have 10 volts and 5 amps. How much resistance do we have in our circuit? The answer is 2 ohms. Remember, the symbol for ohms is the omega symbol, shown at the bottom of this picture. Remember, I said using this wheel allows us to solve any formula in a DC circuit. Everything in yellow is how we can calculate amperage. We used this formula, E over R, to solve for amperage, or I. This part of the wheel gives us 3 ways to solve for voltage, or E. We used this formula, I times R, to solve E, or volts. This part of the wheel gives us 3 different ways to solve for ohms, or resistance. We used this formula, E over I equals R, or ohms, how much resistance is in the circuit. The part of the circle we haven't discussed yet is watts. The definition of watts is heat dissipated. Watts equals power, and the symbol for watts can be W or P. To remember how to calculate watts, remember the word pi, P-I-E. P, or watts, equals I times E. Current times voltage equals watts. Here is the part of the wheel where we can calculate watts. there are three different formulas to find wattage. The formula that we just discussed and that you should know right now is from the word pi. P equals I times Z. Remember, watts is heat dissipated. A 100-watt light bulb feels hotter than a 20-watt light bulb.